It's my first time at Build Stuff. I am going to move a little bit out of the way. I'm going to go this way for a moment. I am Layla Porter. I am a developer evangelist at a company called Twilio. Has anyone here heard of Twilio? Hands up. Oh, that's a good number. So Twilio is a cloud communications API. We allow you or enable you to use everything from voice, video, SMS, natural language, security in your applications using the languages you're already using. So I'm not here to talk about Twilio, but if you want to talk to me later about it, you can do. I am also the organizer of mk.net. That is a .NET group in my hometown. And I am also a C# engineer. So that's a little bit about me. So I'm going to talk to you about HTTP API security specifically. So this is where you are exposing one or more endpoints publicly in your application, usually returning XML or JSON. And this is exposed in the public web and via a HTTP-based web server. So why are we seeing so many more exposed APIs now? We used to have everything in a server. We'd have everything rendered server-side and served up, and everything was closed with one entry point. Now, we're seeing an increase in things like microservices. Each microservice needs an exposed endpoint, needs its own security. We're also seeing things like Angular, React, Vue.js, they all need to make calls to your exposed API endpoints. So we're needing to think about this a lot more. Additionally, you may be giving your API and your services to an external company, so business to business. Excuse me. So what I mean, So what I mean by that is you are having a different front-end framework per business. They can implement their own front-end, but use your APIs. So what does that look like? You have a server, your logic, your database, everything like that behind your API. So then your end user can come along to your API endpoint and consume your APIs via whatever means you want them to. Additionally, you could be giving that over to another set of developers, and they're consuming your API. Or with the microservices, you are encapsulating different databases, different servers, different logics, all behind one single API. You may even have additional APIs coming into that and behind your API. And all of that then gets exposed to the end user. So that's where you need to be thinking about your security. So today I'm going to talk about the common attack vectors you may come across. There's a lot here, so I'm not going to go into too much depth with anything in particular, but we'll get a nice overview of what to look out for and how to interact with it and try and prevent some of these attacks. I'd like to bring your attention first to OWASP. This is a really great website to start with. This is the top 10 security risks of 2017. They are in order. I'd say go and have a look at this. This is going to help you find all those potential security risks, and it does have a lot of insight into how to protect against them. So the biggest security risk you're going to face is humans. We know that. So I want to start with a little bit of a story about what you may come up against. So you may have heard about this story. So Naoki Hiroshima had a very rare Twitter handle, @N. He was offered $50,000 for it. He was always having passwords reset as people tried to gain access to his Twitter handle. So one day he was eating lunch and he got a message from PayPal saying, we've had a request to reset your password. And he thought nothing of it because it happened all the time. He then later got another email. Well, he checked into his email and saw that the most recent email was from GoDaddy, his domain provider, which was saying, your domain and settings have all been updated. And he's like, they've been updated, but I haven't done it. So he then tried to log into his GoDaddy account and couldn't. So he then phoned them up and tried to give them the last 6 digits of his credit card, but they didn't match because the credit card had already been updated. He then went on to Facebook and realized that that too had been compromised because they had access to his email via GoDaddy. So now his Facebook is compromised, and they contacted him, the hackers contacted him via Facebook and said, this is about your Twitter handle. And he was like, aha, I see now. But his GoDaddy account held all of his business domains. So that was his livelihood in this GoDaddy account. And they basically said, give us the Twitter handle or else. So what choice did he have but to hand over his Twitter handle? So he did that, and then they gave him his password. But they also offered to tell him how they hacked his system. So they actually contacted PayPal, pretending to be an employee of PayPal, and PayPal gave them the last 4 digits of his credit card. Who knows why? Why would someone need the last 4 digits of anybody's credit card when you should know them if you have them? So they got that. The hackers then contacted GoDaddy, and they required the last 6 digits of your credit card. So GoDaddy said, well, you've got the last 4. Why don't you guess the first 2 of the 6? So the hackers went, okay, we'll guess. And they managed to guess correctly after a few times, and they got access. So this Naoki Hiroshima lost his Twitter handle because of this. Now, this guessing is effectively brute forcing the human. So you will have this human element, but we can't handle that. We can't really deal with humans and their stupidity or our stupidity. We can only deal with what's in our applications. So let's go on to brute force, as we've just had a look at brute force. And what is that? So this is where a hacker will repeatedly try multiple passwords and passphrases on a particular username. Now there is a reverse brute force where they will try one password or passphrase across multiple usernames. So there's the 2 ways of doing it. So we're going to look at just the straightforward brute force attack where someone will try multiple times to the one user. So this is kind of what happens. They keep trying. They'll try all combinations until they eventually get the right password and into your private details. So the first thing you've probably experienced is account lockout. So you will try your password 3 times on your account, and then if you get it wrong 3 times, that's it, you're locked out. Now, this can create a denial of service across multiple user accounts if they try the reverse brute force account. So say they try and hack 100,000 users 3 times, everybody's locked out of your service, which wasn't not ideal, is it? So another one is progressive delays. I've not come across this in an application. Has anyone come across it? I guess I'll explain what it is first, and then you can tell me. So this is where you'll go in, you'll enter a password incorrectly once. So you're locked out now for maybe 1 minute. You'll try again, and you're maybe locked out for 5 minutes. And then on your 3rd attempt, you may be locked out for an hour, and it progressively longer. So who here has seen that in action? Oh, good for you. Okay, so it's just me who's not seen that. Now, I do know that this is much more difficult to program. So this is maybe why we don't see it as often. But it is exceptionally good at preventing automated tools because they can't just keep going into that application trying to hack it. They can do it once and then they're locked out. So it's good in that respect. Now, the next one is challenge response. Now, I'm convinced everybody in this room has had a challenge response. So this is where it will check to see if you're human. Hopefully we're all human. And therefore, we have all done the Google reCAPTCHA challenge response. Anyone not done this? Yes. I knew you will all have done this. Okay, so this is a really good way to check if someone is human, because a computer cannot analyze these images as we can. So that's a really good way of adding in security. The last way, becoming the most popular now, is two-factor authentication. So this requires something you know, like a password in your head, and something you have, like the telephone in your hand. So there are several ways that this can be done. You can have an SMS push notifications. You can have a telephone call. If we go in here, you can use time-based one-time passwords. This product is Authy. It's a Twilio product, so I'm going to do a shameless plug on Authy there. You get this timed, maybe 20 seconds, you get this password, and then it renews. So it's on your phone, so that's something you have. And that will be in addition to something you know, such as your password. I don't know if you have these wherever you're from. This is a card reader. So we have these in the UK from my bank. And my card goes into this. I enter my PIN, I enter a code, and I get a code back, which I then enter into my bank's website. And then that is something I have, something I know, which is the PIN on my debit card. So that's another way of two-factor authentication. So that leads me on to our next attack vector, which is DDoS. Okay. So this is the distributed denial of service. This is when multiple systems will attack the bandwidth of your application, therefore making it very busy, and your users cannot get to it. So I think it was Stack Overflow had this maybe in 2012, 2013. So it's quite common. It probably happens a lot more than we realize, but people can mitigate against this type of an attack. Now, this isn't just bot networks and you know, nasty things like that you think. It could be an IP camera in your home security system. It could be your smart lights. If you have like Philip Hue lights or smart lights that you can control from the internet, anything that can run code and be connected to the internet can be hacked and used against you. So that's something to bear in mind. So what can we do to prevent DDoS attacks? Well, there's not much you can do. It's about recognizing and acting quickly, so that's what we need to do. So the first thing you can do is scale. So if you're on a cloud provider such as Azure, you're going to be able to scale your instances of your application quickly, which means you'll have more bandwidth and your users, your legitimate users, can still get into your application. So what is the problem with that? Well, if you don't recognize that something's going on quickly, this can cost you a lot financially. You have this scaling, you could have hundreds of instances on your, say, your Azure or your AWS spooled up. You may not notice for a day because it's all automated, and this has cost you thousands and thousands of euros. So this needs to be in conjunction with, say, traffic monitoring. So this is knowing what your regular traffic to your site is. So you know that, oh, hang on, there's a massive spike in the traffic to my site. Oh, we have a sale. That's okay. I don't need to go and investigate. It's Black Friday. You know, we're selling everything off half price, so we're going to have a lot more traffic. So this is okay. But if you're not expecting that and you get a massive spike in your traffic, you may want to investigate further. So this is where evaluating your hosting partner comes into play, because most cloud service providers will have built-in and free basic protection. So if you go to Azure, they will do traffic monitoring for you. You can set up alerts. So it's really worthwhile looking at your provider to see what their basic free protection is. And lastly, an actual cloud mitigation provider, which is a premium service that you can pay for to monitor your traffic, scale, alert you, handle everything for you. So that can be a good option if you think you're at a high risk of DDoS, and it's really important that you don't have any downtime on your services. There is something you can do, though, which is programmatic, which is rate limiting and throttling. So they're slightly different. So limiting is the speed at which a service can consume your API. Okay, so you may say that they can have as many API calls as they want, but they can't have more than one every 5 seconds, for example. So they can't do 100,000 in 1 second and bring your service down, but they can keep doing that at a limit at a limited rate. The other way is throttling, which is quite common if you have different tiers of service. You may throttle people to say, well, you can only have 100 requests a day, or you can have 1,000 because you pay a bit more. And that's another way that you can throttle back how many hits. So if you're under attack, there could be 100,000 hits on your service from that one IP address. And you say, oh, no, you've reached your limit, and cut them off. So I'm actually going to show you how you can implement this in a .NET Core application, because it's quite quick and simple. So this is just the main. Oh, no, we need to go this way. I need to do this for you. Oh, you're supposed to tell me that you can't see my screen. So coming here, right. Do we want that a little bit bigger? Yeah, okay. So this is the standard template that you can download from .NET New Web API. I've just got rid of some of the other endpoints there, so we just have the get. This is already running. This has no throttling on it. And if I come into Postman, are you all familiar with Postman? Yeah? Okay. So we can hit that, and we can see that we get those values back. That's not overly useful because, well, I'm only hitting it once, and if I put my limits on, how am I going to test that? But let's start by putting the limits on as well. So I am going to use this project by Stefan Prodan, ASP Net Core Rate Limit. It's really easy to implement into a .NET Core application. I'll put the links up to it at the end. And then if I come back into my code here, we can see in the CS proj that it's added already. And then if we go into startup, there is a whole load of configuration here already. So we're adding the IP rate limit options, which I'll show you in a moment. And then we have some policies and a few other bits that's required to do it. So the key here is to add in the use IP rate limiting, save, oh, not delete it, Layla, save it. And then this is all handled in your app settings. So your regular app settings that comes for it, you can see we've got this IP rate limiting here. Now you can be really specific with this. You can see here I have gone for my API/limit, which is the endpoint I showed you earlier. And I'm saying in a 1 minute period, this person can, from a certain IP, can only have 20 hits on my site. Okay, so this is a throttle. We're saying in a 1 minute period, they can only have 20. It could be a rate, but at the moment, we're going to look at it as a throttle. So if we just stop this and then run it again, and then we'll come in here. Now, I need to test a lot of hits at once. So I'm going to use this part of Postman called runner. So if we come over here, I have it set up. This is my endpoint here. You can see it says API/limit. Let me see if I can zoom in a little bit on that. I can. And here we can say how many times I want to hit this endpoint. Now, I set that to be limited at 20, so let's try 25 hits on my API. And then I'll run it. We're getting a whole load of 200s. Now, what I'm expecting when we get to number 21, we should have a 429. And then we do. So we have a 429, too many requests. So already we're saying, nope, you can't have any more. You can't come here. I'm not going to accept anything from you. So how do we limit that? So if I come back into the project, you can build up these. So I'm just going to copy that, paste it underneath. So in this one, I'm going to say, in 5 seconds, I only want you to have 5. So now we're limiting the rate at which they can have their 20 hits. We're saying you can only have 5 in 5 seconds. Okay, so we're going to save that. I shall just restart the project. Come back into here. So I'm still going to hit it with 25. And I'm hoping that we'll only see 5 200s. So let's see. And you can see here that we have the 5 200s, and then number 6 is into 429. Now, if I did that every 5 seconds, it would be the same until we hit our 20 hits for that time period, and then it would all be 429s. So you can see how if you're under attack, that this would be a really good way just to say, no, you can't attack me anymore. So if we go back to the slides, if I just come back here, I want to undo that. Okay, so there it is. So, excuse me, yes? You can do. I'll come to that in a bit. So yeah, that's just on your quick local project. You can put it in. Okay. So the next thing we're going to look at is cross-site scripting. Okay, which is known as XSS. So this is when malicious code is injected into a vulnerable application. Now you may be thinking, my application isn't vulnerable. That's not going to come in. That's not going to happen to me. But maybe you have your site open to comments. Maybe you have, you know, like a blog on there, and you, oh, send me a comment, or you have a form, something like that, where it gets displayed back. So the hacker will take that vulnerability. They'll put some script into, let's say this comment field, and they'll press save. That then gets pushed up into your database, is dished out by your API, and then is served up to your end user. That script may then dish up that user's cookies, and then they can do something nasty and nefarious with it. So there are 2 types of XSS. We have persisted or stored. That's the one I have just described. That's the one you can do more about. It's equally the more dangerous one. And then there's non-persistent or reflected, which is more where a user has to click on a link. Now, we can't stop a stupid user from clicking on a malicious link, so we're not going to talk about that one. So again, I'm going to refer you back to the OWASP cheat sheet for preventing XSS attacks. You can see they have a lot of information on that. So that's a really good starting point. But there are some things that you can do, which is mainly input management. So this is escaping, validating, and sanitizing your data when it comes in. So if you have chevrons, angle brackets in your code and a script, you want to get rid of those, or you want to stringify them so that they can't be run. It renders scripts completely, you know, helpless if you stringify them. They can't be served and run. So that's a good start. Validating. Trust nothing that comes into your application. You should all know that. Trust no one. Even if it's B2B and it's a trusted business partner, who are they exposing it to? And their data that comes from their users can come through them and to you. So really trust no one. And then sanitize your input. This is especially relevant if you're having HTML input. So you want to make sure that you're removing any embedded JavaScript in those tags. Get rid of it all. Just make sure that there's nothing in it that shouldn't be in there. So just sanitize everything, stringify it, parse it, make sure it's all good. The other thing is HTTP only cookie flag. This prevents JavaScript from accessing your cookies. It's protected, the browser can only access it. So these malicious scripts, if they manage to get in, they can't actually do anything with your cookie. They can't get to it, they can't send it off to a hacker. It's all protected. So that's a good thing to look at. Now, SQL injection attacks. This one, I am going to touch on it, and you may be thinking, oh, not SQL injection attacks. That doesn't happen anymore. I'm going to refer you to the OWASP Top 10 Application Security Risks of 2017, last year. Can you see what is number 1? SQL injection attacks, still. So it is still a problem. I won't spend too much time on it, but just in case you're unsure of what it is, here is one. My username and my password. So I have a statement of truthiness, 1 = 1. And then I go into my malicious query, drop star from users. So I've guessed that your user table might be called users. It might not be, but it might be. So I've now put that in, and bye-bye database. Okay, that's all your users gone. That is essentially a SQL injection attack. Now, you may not be worried because you might be using Entity Framework, you might be using some other ORM, DAPA, even stored procedures. They're all going to give you a level of protection because they parameterize the inputs from your users. You're more concerned about this if you're using ADO.NET. So make sure that everything that comes in from the user, that you're not putting raw data from a user into a query to your database. Okay, so just don't do it. For more information, I refer you again to the OWASP cheat sheet. There's a lot of information. So if you're worried about that or want more information, check that out. Okay, so next of us is CSRF. I just want to refer to this little ant. He is infected with the cordyceps virus. Is anyone here a gamer? Yeah? Anyone played Last of Us? Yeah? Yeah? Cordyceps. And I like to think that cross-site request forgery is kind of like that cordyceps fungus infecting you, getting you to where you want to be or where it wants to be for the perfect environment, because it's piggybacking on you, zombifying you, and that's what I think CSRF is. So just to go into a bit more detail, you will get a phishing email, or the user, from the hacker, and that user will click on the link, and this is dependent on that user being logged in and authorized to your application. So now you're logged in and authorized, we can make a request to your API. And your API thinking, oh yeah, they're logged in, they're authorized, this is all good, and they're asking me to transfer €1,000 to this person over here. Okay, so that's what it will do because it's logged in and authenticated. So this seems like something we can definitely work on. So we want to use good authentication methods, such as API keys or sophisticated mechanisms such as OAuth. This is going to stop that sort of being logged in for days at a time unless the author does it. You're going to have to renew these on a set time base. So let's have a look. You've probably all seen OAuth. This is the account creation or sign up for Stack Overflow. You can sign up directly with Stack Overflow, or you can use Google or Facebook. So this is where you can use a trusted third party to verify your user, say yes, they are who they say they are, and pass them into your website. Now, there is a good point to having this. It means that you don't have to worry about storing passwords and usernames and encrypting them and saying, oh, can you have 10 characters, 2 uppercase, and a couple of exclamation points in there or whatever. You don't have to worry about that. The OAuth partner will handle that for you. It just says, yes, this person is who they say they are. Here is a token, and off you go. I will say that a lot of users maybe don't want to use OAuth, so you may be forced to have both. I personally don't like to use OAuth features. I'm maybe wrongly, I always like to register with the site directly. But, users don't always want to use these third parties, so just bear that in mind. Okay, so origin and or referrer header. I'll also add in the host header there as well. These are protected headers. Only the browser can access those, not JavaScript. So it does make them quite strong CSRF defenses in their own right. So with the origin and referrer, you're checking, is this coming from where I think it is? Yes, okay, proceed. No, I don't know this origin or that referrer, go away. So this is, quite a good way of checking that it's coming from the expected source. The double submit method. So this is where you will have something, a token or random nonce, some sort of little key that you put as a parameter and in an encrypted, in a cookie that has the HTTP only flag set. That's an important factor here, that flag is set. So, excuse me, when that request comes back in, the server is going to say, does this parameter match this cookie? If so, yes, okay, this is good. If not, this is a little bit suspicious. Someone has fiddled around with this parameter and I'm not going to trust this. So that's another way. Encrypted token patterns. In MVC, have you used the anti-forgery token annotation on something? Anybody? Yeah? Good. One person over there. So I'm hoping a few more have used that as well. That uses this encrypted token pattern. So it takes the user's ID, a timestamp, and maybe a nonce, so just a random value, or maybe a GUID, something like that, and then it encrypts them and does all stuff with them, and then it shoves that into half in the cookie and half into a hidden field on your application. So this is a little bit harder to do with a web API project, but you can still do it. It's more traditionally done with an MVC project, but it doesn't mean you can't do it. So if that comes back and when the server puts it together or matches them, it can't decrypt it. It goes, there's something wrong here, I can't decrypt this, I'm going to turn away this request. So that's another good way of doing it. And then, as I've mentioned, that HTTP only flag. So that's really key just to making sure that we've got all of these cookies protected. Okay. So some further ideas. So earlier I mentioned things like API services, paid for premium services. This covers, was it your question? His question, this will cover your question more, okay? So with API management services, they do take the hassle out of your API management. Most major cloud services will offer this, so Azure, IBM, MuleSoft, AWS, you Google it, there are countless services that will handle this for you. They can be expensive. So I know that for Azure, you're looking maybe €1,500 per month. But if your site is, high capacity, high risk, that may be a drop in the ocean for your customer trust and a whole load of other things. This could be really money well spent. the other thing about a lot of these services is that you don't have to do a lot of what I've just talked about. They do it for you. It's also good if you have an existing project that you want to update to be an exposed API, because some of these services will go through all your sort of endpoints and your controller actions or whatever and say, this is going to be an endpoint. They'll produce documentation for your users. So they are really good. So this is Azure's one. Monetize your data and services and open new channels to customers using Azure API management. So you can make money out of these. Well, they're making a lot of money too. So you can go through that and set up your whole API. So this will monitor everything. It will look at your traffic. It will scale if it thinks that this is normal for you, and it will keep going through all those sorts of things and manage your application for you. So that might be really worthwhile. IP whitelisting. So this is a little bit of an odd one. Now, I came across IP whitelisting. I worked for a telecommunications company before Twilio. And this was for handling incoming telephone calls from different carriers and routing them through. So we knew which IP addresses these calls were going to come from, and we could whitelist them. And if they didn't come through that call, then we weren't even going to accept that. So what you can have is your IP whitelist. So this works mainly for business to business because they need a fixed IP address. You need to know that it's going to be this specific IP address, and you're going to allow that to come into your application. It doesn't just come in and have free reign. It then has to go and be authenticated. But this is sort of a bouncer at the door to say, you're not even welcome here, let alone able to be ID'd. Okay, so it just puts them that extra layer of security there, but can't be used on its own because IPs can be spoofed. We also have the human element here. You have an IP whitelist here that can be edited and added to. So you could have someone naughty in your company that goes and says, I'm going to give this IP address the whitelist, I'll put it on the whitelist, and then this is someone who you haven't authorized, someone naughty in your company has authorized. So you also need to be wary of that type of thing. Okay, so it's an additional layer, shouldn't be used on its own. Okay. Now I did say I would talk briefly about JSON Web Tokens, or JWTs. They're often known as bearer tokens. You will see these used a lot. Most programming language libraries will have some kind of JWT, or I hear they're supposed to be pronounced as JOTs. JOTs? I don't know. I saw that recently. I was like, no, it's going to be a JWT forevermore. But they will create them for you. So if we have a look at the structure here, we have a header separated by a period, payload, period, signature. So you can see that the corresponding color coding there as well. So what is that? The header has the algorithm and token type for your encoding. So this is HS256, and we're having a JWT. Then the payload. So this is the actual data that you want to access and use. So this could be the name of someone. It could be, a timestamp. It can be anything you want. I'm just going to put a star on that one and come back to it, okay? And then you have your signature. So you will have a secret, and that's a 256-bit secret. So you might use a passphrase, a string, like anything you want, really, or you might choose something, I don't know, good and stringify that. But you can do whatever you want as long as it's big and secure, and that will encode it. So that brings me on to be careful what you put in there and where you store it, because they are encoded and signed, not encrypted. Okay, so I can come in and just do that. So if I could bring you out to here, I'm going to come here, mirror this, and then come back. Okay, so this is jwt.io. You can put any token that you find on your website, anything you like, pop it in here, and it will tell you what puts out. So I can also make them in here. So, oh, well, we don't have internet down here, but it might work. So John, well, let's just put the name, build stuff, and you can see that it's updating the encoding, the tokens changed to match that. Okay, so you can come in and have a play in this jwt.io. So if I come over to this one, here's one I made earlier. I've unencoded this, or decoded, I should say, and now you have my username and password, my super secure password of password1. So this is why I'm saying be super careful what you put in these. Don't put sensitive data, just be really sensible. Obviously you need stuff in them because you're using them, but just be careful with them, or don't use your local storage, shove them into your the cookie with the HTTP only flag. Just be really careful with them. So come back in here. So that was those. So I've covered quite a lot in there today, from tokens, management services, the major threats that you have on your site. And I hope that that's given you a little bit of insight into the problems that you might come across. So notable mentions, OWASP site, so that's www.owasp.org. The ASP net core rate limit by Stefan Proden is the NuGet package I used for my rate limiting and throttling. So you might want to go check that out. If you are not using .NET Core and you're using Framework, you can still do this. It's a little bit more involved. You will probably make an annotation for your code, and you'll handle it a little bit more programmatically yourself. If you Google it, there are so many different tutorials that tell you how to do it in Framework. So, or I can help you. You can ping me and I will point you in the right direction. And then I also spoke about Authy.com for two-factor authentication if you fancy having a look at that. So, lastly, I really want to say a big thank you to everybody.